This video is going to look at the concept of goodness of fit. So here I have four different outcomes, A, B, C, or D. And I observed 11 times something happened with A, 9 times with B, 10 with C, and 10 with D. The expected value, where does this thing come from? Well, it may be given to you, but where it's coming from is if there is no understood or expected percentage what you expected from A or expected from B, then you assume that there are four possible choices and you divide the total by 4. So if you add up 11, 9, 10, and 10, you get 40. And 40 divided by 4, because there are 4 possible outcomes, is 10 each. And so you divide it evenly among the 4 outcomes. If there were 6 outcomes, you would divide the grand total by 6. If there were 10 outcomes, you would divide the grand total of observed by that number. That would give you what you would have expected and an even distribution and equally likely on all possibilities. Now, to get the test statistic, you're going to go to Stats, Goodness of Fit, chi-squared test, and you're going to select Observed for the observed column, and for expected, you'll choose expected. Okay. You can choose, you don't have to show that expected. If they're all equal, you can just check that box. And then you click compute. And this is what you're going to get. So my chi-squared test statistic is 0.2. My degrees of freedom is 3, because there were 4 items. Minus 1 is 3. 40 items altogether. The critical value, how do I get the critical value? Well, the critical value is going to be used with a calculator. And I'm going to use the chi-squared calculator because it's a different distribution than what we've been used to using. And here we have the chi-squared calculator. I'm going to put in 3 degrees of freedom. Okay. And I want the critical value, so I'm looking for this number here in this box, and I will put in what percentage is off to the edge, and that is going to be 0.05 because that's the beta, the alpha that was given to me, and I compute. Now, this would assume less than, but there's a mistake here. Don't leave this as less than. Remember, you're looking for the area in the tail, not in the body. So make sure you change this to greater than before you do the calculation, and this needs to be 0.05. Now do your calculation. This is what you're looking for. You're not looking for less than, you're looking for greater than. Okay? Now, on the other hand, you could have a situation where, in this case, okay, we have, there's my items, and I have 1, 2, 3, 4, 5, 6. If they were all, if the expected number was equal, then I would just take the grand total here and I would divide it by 6. But that's not the case in a problem like this. Usually they give you a percentage. So they tell you that this percentage is 13% of the grand total. The expected value would be 13% brown. So what you do is you come to your calculator, you add up all of these, which comes out to 398 for this particular example, and you multiply it by 13%. So my expected value is 51.74. And I do the same thing for the next one, yellow. My problem assumed 14% were yellow, and so I go back to my calculator and I take 398 and I multiply it by that percentage, which is 0.14. I get 55.72. 55.72 I get for that one. And then the next one, my reds were 13%, so I have another 51.74. And I would do the same multiplication in each of these cases. The blue ones was 24%, so it would be 95.52. And the orange ones were 20%, and that would be 79.60. And for the green, it was 16%, so that would come out to 63.68. Now that I have my observed and my expected, I can go back here to my goodness of fit chi-squared test. I will select my observed, I will select my expected, and I will compute. And here, these are my the expected. Here's my, there are 5 degrees of freedom, always one less. Here's my p-value, and here's my chi-squared number. And I can make the decision that this p-value is less than 0.05, so therefore there is sufficient evidence to conclude that the data is not the same as stated. In other words, there is a significant difference in the observed from the expected. I hope this helps you with this type problem. Thank you.